Well, hello guys, and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to continue with the lessons regarding momentum and impulse for grade 12. It's a very good topic to score marks in the examination. But before we move on, don't forget to subscribe to the channel and like the video so you can get notifications and videos I post on a regular basis. I'll be back in a minute. Well, now in this video we're going to be doing the law of conservation of linear momentum. We're going to be distinguishing or identify the different type of collision, and that is the objective of this specific video, guys. At the end of the video you should be able to distinguish between the different type of forces that they are in this specific topic. We are going to define an isolated system. We're going to state the law of conservation of linear momentum, and then we're going to identify, differentiate between the different type of collisions. Quite important for the exam. So let's dive into the question. Now, first of all, let's classify forces. Now, forces, we remember forces are vectors. Just going to point out that one can be divided into main groups. Those are the external and the internal. External forces or internal forces. Now, the internal forces are the forces within the system. This is forces within the system. All right. For example, if we have this collision between two cars, the force that one car exerts on the other car, that is an internal force. Let's, for instance, say that this is our system. For example, this here is our system. So everything that is within the system is what we call internal force. So if we call this one A and this one B, the force that A exerts on B and the force that B exerts on A, those are what we call internal force. Alright, they are equal in magnitude and opposite in direction. That's Newton's third law, but it's not important at the moment. You need to know that those are what we call internal forces. Now, the external forces are forces from outside, out of the system. Out of the system. For example, in this situation we have in which the system is only the cars, the frictional force is going to be external. The only forces that matters in this system is the forces that one car exerts on the other car. Everything else is what we call external forces. This is the classification of forces, and it's very important. Now, if all the forces that act on the system are internal, then we say that that system is isolated. So let's define isolated system. System that the net external forces is equal to 0. That is when the system is isolated. If the net external forces is equal to 0, the change in momentum is equal to 0. All right, now where is this one coming from? Well, guys, remember that F net is equal to change in momentum divided by change in time. So if the net force is 0, then the change in momentum is also going to be 0. This, you can rearrange this one here. And guys, this one is what will lead us now to the law of conservation of momentum. The law of conservation of momentum states that the total momentum of an isolated system remains constant. If it remains constant, it means that the total change in momentum is equal to 0. If the total change in momentum is 0, it means that the total momentum initial or before the collision is going to be equal to the total momentum final or after the collision. As usual, I am going to keep the vector sign here. Now, we are speaking about collision, we're speaking about interaction, so there are more than one object involved. The total momentum initial will be the addition of the momentum initial of object A plus the initial momentum of object B, and I'm going to keep the vector notation. And the total final momentum will be the addition of the final momentum of object A plus the final momentum of object B. That is the law of conservation of momentum. But remember that momentum is the product of mass and velocity of an object. It's an important definition. Let me get my coffee as usual, guys. So now here, if we substitute the product of mass and velocity of an object in each of the momentum formula, we have that the initial momentum A will be mass A multiplied by the initial velocity A, and this will be plus mass B multiplied by the initial velocity B. Also, I'm going to keep the vector notation, but at the moment, you really don't need to. This is equal to mass A, final velocity A, plus mass B, final velocity B. Guys, this is the law of conservation of momentum. Wow, Mr. Gomez, which one is the Mr. G, which one is the starting point? Guys, you can start from here. So you don't have to do everything I did here. I am just showing you how to reach this point. But you may in the exam start from there. I do not recommend you start from any step after that one, but rather from there as a starting point. So this one is my recommendation and this one is the law. The total momentum of an isolated system remains constant. Keywords here, guys, and let me just highlight keywords. Total. If you miss the word total, you won't get marked. Second, isolated system. If you don't speak about isolated system, you lose the mark. So those are important words that cannot be missed during the exam when they ask you to state the law of conservation of momentum. Let's practice a question and you'll see that it's actually quite simple, this work. This question says a rifle of mass 4 kilograms fires a bullet of mass 3 times 10 to the minus 2 kilograms at an initial speed of 700 meters per second. Calculate the velocity with which the rifle strikes the gunman's shoulder as it recoils. And now you have a picture of a man with a rifle and is trying to shoot a bullet shoot the rifle. Okay, so what is going to happen? The system is not the man. That man is not part of the system. Our system is the bullet and the rifle. The man is not part. It's an external factor. Okay, so it's not. We're not going to even consider that man. I think we are going to write the data right in this picture before we start answering the question. All right. So let's track the data here. In this one, so data. Now, remember, before data, we need to deal with direction. In this case, the bullet is moving to the right. We're going to take right as positive, and I highly recommend you to do that during the data. So I'm going to write here, right, positive. All right, I like to do it during the data while I'm striking the data, and I always strike data. It doesn't really take that much of a time. So now here, mesh 1, I'm going to take rifle as mesh 1, that is equal to 4 kilograms. Mesh 2, which is the bullet, is 3 times 10 to the minus 2 kilograms. Now, the speeds, be careful. That 700 is after the rifle have shot the bullet. So that is actually the final speed. The initial speed, 1 and 2, initial speed 1 is equal. Let me see how can I write this one. The initial speed of 2, which is equal to 0. That is when the rifle and the bullet does before shooting the rifle, the bullet, and is at rest. So the initial speed is 0. The final speed, 1, that is what we are looking for. Remember I said 1 is going to be the rifle. So final speed, 2, that is the 700, which is positive, 700 meters per second. That is the data. So using the data, now we're going to draw. Remember I said we can start from that specific point. So we're going to start from there. M1, V initial 1, plus M2, V initial 2 is equal to M1, V in final 1, no initial. I always making this mistake here. Final 1 plus M2, V final 2. There we go. I'm going to, as usual, include the vector notation. You don't have to. So now, guys, it's to substitute. It's to substitute. Now, not the following. I'm going to do something because before the collision, they are together. So the speed, even though it's 0, is a common factor. I'm going to write it now like that. So this initial part, like this one here, we can actually say that the initial velocity bracket is multiplied by m1 plus m2. This one we can use it, but just don't recommend to start from there because it's not always like that and you can lose marks. So we're going to do like that. V initial multiplied by m1 plus m2 is equal to m1 v final 1 plus m2 v final 2. Guys, and the rest is to substitute in here. So now the initial speed is 0 for both of them. The masses are 4 and 3 times 10 to the minus 2. 4, 3 times 10 to the minus 2. And now we're going here. 4, v final 1, that is what we are looking for in here. I have my coffee. Plus m2, which is 3 times 10 to the minus 2. Yes, I just want to make sure. 3 times 10 to the minus 2 multiplied by the velocity, which is 700 positive. Guys, when you do this calculation, I have done all this one already. I just want to, this one is 0. I just want to redo it just in case. So this one is 3 times 10 to the minus 2 multiplied by 700. This one is positive. You go negative divided by 4. You get that the final speed or velocity, they ask for velocity, of the object 1, which is the rifle, is equal to 5,25 meters per second. This one is negative. Let me just write all this one properly. It's equal to minus 5,25 meters per second. Now, guys, I highly recommend you to write the direction in words. So the final speed or the final velocity, not speed, of this object is 5,25 meters per second to the left. There we go. And that is the answer of the question. It's quite simple. It's really simple. If you take the data out of the question, you should not struggle with this one. All right, so now we're going to the next part of the question. We have two types of collision. We have elastic collision and we have inelastic collision. It's really, really simple. The elastic collision is that collision that the momentum is conserved and also kinetic energy is conserved. So in this case, we can say that the total momentum initial is equal to the total momentum final. And in this type of collision, we can say that the total kinetic energy initial, let me write it here, is equal to the total, this is total, total, oh my goodness, EK total initial is equal to EK total final. That is for, there is no vector, no vector. That is for elastic collision, right? Now remember that kinetic energy, guys, and this one is just now a reminder from grade 10, kinetic energy is equal to half mass multiplied by speed squared. This is speed, this is not a vector quantity. So when we're dealing with kinetic energy, the direction is not important. Now in an inelastic collision, in the inelastic collision, only momentum is conserved. In other words, in this inelastic collision, the total initial momentum is equal to the total final momentum, but the kinetic energies are not equal. So the total kinetic energy initial is not equal to the total kinetic energy final. That is important to have in mind. So those are the two types of collision, and we are nearly to the end. We are going to now look here at an example of one calculation using this one and obvious identifier. So this question says collisions happen on the road on our country daily. In one of these collisions, a car of a mass 1,600 traveling at speed of 3 meters per second, 30 meters per second to the left collides head-on with a minibus of mass 3,000 kilograms, 3,000 kilograms traveling at 20 meters per second to the right. The two vehicles move together as a unit in a straight line after the collision. Now, there is the picture, and the question says, state the law of conservation of momentum in words. Calculate the velocity of the two vehicles after the collision and identify the type of collision doing calculation, okay? So, and this is going to be the end of the video when we finish this question now. Question 2.1. The total linear momentum is constant in an isolated system. There we go. That is the law. Now, second, 2.2. 2.2, calculate the velocity of the two vehicles after the collision. So let's write the data, and let's write the data on this side. Data. Let's take right as positive. It doesn't matter which direction you take as positive or negative, you'll get exactly the same answer. So now here they say, in one of these a car of mass 1,600, so let's take mass of the car as a mass 1, so it's equal to 1,600 kilograms. They say here, traveling at speed of 30 meters per second to the left. So the initial velocity 1 is equal to negative 30 meters per second. Negative because we say right is positive. The question is telling you that it's traveling to the left, it means it's negative. So it collides head on with a minibus of 3,000 kilograms. M2 is 3,000 kilograms that is traveling at 20 meters per second to the right. So the initial velocity 2 is equal to 20 meters per second positive because it's to the right. And then final, they say they move as a unit, calculate the final velocity of the two cars. So the final velocity of both of them is what we are looking for here in the data. So we are going to apply the law. And the law we're going to start, as I told you, from the same starting point, M1 V initial 1 plus M2 V initial 2 is equal to M1 V final 1 plus M2 V final 2. Now, because they're moving together as a unit after the collision, we are going to sort out, let me move this one here, we're going to sort out that second part of the final. So we're going to keep this one, M1 V initial 1 plus M2 V initial 2 is equal to the final velocity is the same because they are moving together. It's a common factor. And then multiply the addition of mesh 1 plus mesh 2. Guys, we are ready to substitute. This one is not necessarily a step. You can substitute even without doing this one and you will get the answer. So M1 is 1,600. V1 is negative 30. This one is 3,000. Positive 20. VF bracket 1,600 plus 3,000. Guys, this is just calculation. So let me do it real fast. I want to do it real fast. It's 1,600 times 30. This gives me 48,000 negative. 48,000 plus, and then this one is 3,000 times 20. This one gives me 60,000. And then this one is 4,600. This is VF multiplied by 4,600. Okay, so that is what we have, and the rest is just to finish that easy calculation. So it's 60,000 minus 48,000 divided by 4,600. We get that the answer is the final velocity. I'm going to write it here. Is equal to 2,61 meters per second. Let's write it here at the bottom. Final velocity is equal to 2,61 meters per second. The question asks for, and let's make sure, calculate the velocity. So we need the direction. This one is going to be right. The answer is positive, and we said right is positive. Now, the last part, they say identify the collision. They say the collision is inelastic. Anyway, you have to identify. So you have to do calculation. Now, how we do this one? We are going to calculate the total kinetic energy initial and the total kinetic energy final. And we are going to do it separated. So we have here, this one is question 2.3. Kinetic energy total Let me write it. Kinetic energy total initial is equal to kinetic energy 1 plus kinetic energy 2. This is initial. All this one is initial. So this one is equal to half m1 v initial 1 square plus half m2 v initial 2 square. We always do it like this, separated. We first calculate the total kinetic energy initial, then we calculate the total kinetic energy final. So let's substitute. We have that is half, the mass is 1600, multiplied by the initial speed, which is given 30. No direction needed here, guys. We don't need the direction here. This is plus half 3000 multiplied by 20 squared. And this is the total kinetic energy initial. Let me just do all the calculation, guys. That is what we get for the initial kinetic energy, for the total initial kinetic energy. So now we do it the same, the kinetic energy total final. This one is equal to the addition of the kinetic energy final of both of them. So it's half m1 vf1 squared plus half m2 vf2 squared. And then, guys, we substitute. And you get that the final answer is 15667,8. Guys, you can do the calculation yourself. It's not a big deal here. And now we get that the total kinetic energy initial is not equal to the total kinetic energy final. Therefore, the condition is inelastic. Guys, this is the end of the video. I thank you for watching. I hope it helped. It's a good question to practice here. Then next time we're just going to do another video just on practicing the work. So I hope it helped. If it helped, thumb up. Thank you for watching. I'll see you next time.